go on to the next system here. This one, we have a video of this one as well. So this is a good one that shows how well we have control of the system, of the motions of the system. Peng alluded to, it looks like we're just really slamming these parts together and we're very rough with them, but that's absolutely not the case. So this video is of what we call a proof of principle test, or a POP, where we basically test a critical operation or a critical assembly process step. So that is absolutely the case here. This is a glass syringe that's being installed into an auto injector. So if you a pre-filled syringe. So think like EpiPen or the Narcan type injectors. That's what's going on here. So the pre-filled glass syringe is of course full of a sterile liquid, and if you do not if you insert that glass syringe body into the auto injector too rough, too fast, too forcefully, you can basically dislodge the stopper, or I'm using a very simple term there, and risk breaking sterility. And that's, of course, a critical failure. So we cannot deviate from that established, validated process. So to do this at rate, traditional automation, our competition in this particular case, needed 40 tooling nests to accomplish this process. That's 40 tooling nests. And we did it with 4 nests. And I'll play the video here, and you can see first a high-speed version of it. This is only one up tool because we were just testing. Here's a slow motion view of that same test. And this being the critical process here, where we're inserting the body into the auto injector. I think our video might have stalled there, but again, so the competition required 40 nests to accomplish this process, and we did it with 4. Now, we absolutely did not alter the insertion timing, the insertion speed, and the insertion forces that were required here. That was just a no-go. So how did we get done with 4 nests? What our competition was using 40 is really a study in lean manufacturing. So many of you are probably aware of Muda, Japanese term for waste. There's necessary waste and unnecessary waste. In this case, if you look at this process step on a very microscopic view here, the only value add step here is the actual insertion of the syringe, the glass syringe into the auto injector. Everything else is waste. So we can't eliminate the pick and place motion of going back and grabbing the syringe body and bringing it forward and ready to insert, but we can reduce that. And we do that by just going as fast as possible during non-critical portions, and then slowing down and carefully accomplishing the critical value add portions. And that is what we did here. And the result being almost 70% of the cycle time was dedicated to that critical process step, and 40%, nearly 40% was the pick and place motions of moving away from the part and bringing it back. Because of the way we do this assembly process, we actually eliminated the pre-insertion quality inspection and the post-insertion quality inspection and integrated those into the system. Those quality checks were just done with the Symphony tooling. Again, 40 tools versus our 4 tools at 320 parts a minute. 80% reduction in floor space because of the number of tools required, and 90% less tooling with our system versus the traditional automation.